That's right, today we're taking a look at the Ember 3D printer from Autodesk. We've been printing our projects for several weeks and wanted to share some of the workflows and techniques.
This is a DLP SLA 3D printer, so it's completely different than all the 3D FDM printing we've been doing. So here's a basic look of how it works.
So this printer uses a DLP projection to cure photosensitive resin using a UV light.
The projector shoots UV light as one full slice for each layer, and this can print in resolutions of 10 microns.
So the metal build plate moves up along the Z-axis and prints emerge from the resin tank.
The Ember printer uses a cure and peel technique. This is where it exposes and separates for each layer to create a high definition part.
So when the UV light is exposed to the resin, it's hardened and solidified. The resin tank then separates and moves away from the build plate and then returns for the next layer.
And this does this for like every layer. Enclosure parts that are smaller than 30 millimeters can actually print without any support material. STL models themselves are going to get prepared using Autodesk's mesh mixer, and here you can set up your support structures to hold onto the models to the print head.
So setting up the proper orientation for an object can be a little tricky. You'll want to test different angles to get the right orientation. You'll also want to keep in mind that parts are printed upside down. That's because the print plate is oriented that way when printing.
So you can optimize support structures to print with the tighter hold by upping the tip diameter. Under the support generator options, you can update the defaults from 0.15 millimeters to 0.5 millimeters. And this is going to increase the width so it holds objects more firmly, making print fails actually less likely. You can also add your own custom supports here to accommodate for any overhangs.
Next up, we're going to need to slice the model up for printing. This is done through the Ember printer website. Here you can preview models to make sure everything fits correctly. To speed up prototyping, we can print at a lower resolution of 50 microns and then adjust the exposure time to 3.5 seconds.
The slice preview lets you visualize how the part's going to be printed, and it's actually just a stack of PNGs. You can also monitor your print job from any mobile device.
Okay, so to operate the printer, you're going to need to handle the resin with safety in mind. So you must wear gloves, safety glasses, a lab coat, or an apron, because, you know, safety first.
Each print needs to be cleaned and processed, and this can get a little messy. So it requires a cleaning station and handy tools that are specialized for handling those resin parts.
So your tools, containers, and anything you touch are going to get resin on it, so you need to be cautious.
Now let's take a look at removing support material. So to remove the support material, we recommend using flush diagonal cutters. And you can start by snipping off the tips from the supports and then removing branches as larger groups. You want to try to cut the tips away from the part to prevent any surface damage. We definitely recommend wearing a safe shield to protect yourself from any flying bits, especially when you're breaking apart those smaller pieces. And you want to take your time, especially when cutting complex structures. And if you have support structures inside of your model, you can use tweezers to hold them in place while snipping them into smaller bits.
Okay, so now after your parts are printed, you'll need to fully cure them by submerging them inside of a plastic jug full of alcohol. You're going to need to let it soak for about 5 minutes before taking it out and patting dry with a paper towel. Rough edges and support bits can be sanded away, but it leaves a chalky look. So this can be fixed with a little bit of mineral oil.
Now let's take a look at maintenance. Keeping the resin tank clean is really important. When prints fail, material tends to build up and float around the tank. This can be a little bit difficult to spot, especially with clear resin, so we're going to use a hair comb to filter out any pieces that are left behind. You can also use tweezers to fetch out any of the larger pieces, and we recommend carefully swiping around the edges of the resin tray window and remove any buildup. If there's a lot of bits and pieces, especially after a failed print, we recommend using a fine mesh strainer to quickly filter out the smaller debris into the second tray that comes with the printer. The build head itself is easy to clean after each print, just wipe off any remains.
Okay, so let's take a look at the leveling procedures. So we're going to need to re-level the build head before starting a new job, mainly because it misaligns after removal. So we can start by loosening up the build head and moving it up. Then we'll initiate the leveling process. It'll start homing the build plate down until it reaches the resin tank window. From here, you can loosen up the build head and let it drop on top of the window. You'll then need to push down on all 4 corners to lay it flat. Once it's all straightened out and leveled, we can tighten it back up and then complete the process.
Now to finish up, we'll go ahead and clean the outside of the tray using a paper towel. You'll definitely want to be careful not to rub off the ink from the minimum and maximum labels that are on the tray, because you kind of need those.